In this module, we will again talk about the medium sterilization, but actually in this module we will talk about the rapid method for the designing of the sterilization cycle, following by the Richard methods. So as concerned, the Richard 1968, he proposed a rapid method for the designing of the sterilization cycle, avoiding the time-consuming graphical integration as we have seen over our previous module. So the method assumes that all the spore destruction occur at the temperature above 100 degrees Celsius, and that those part of the heating and the cooling cycle that is above 100 degrees Celsius are linear. So when we go beyond 100 degrees Celsius, it means the destruction is linear. So both these assumptions reasonably valid, and the technique loses very little in accuracy and gains considerably in simplicity. Furthermore, based upon these assumptions, Richard has presented a table of the Dell factors for Bacillus stereothermophilus spores, which could be obtained in heating and cooling a broth up to and down from the holding temperature. If we say that the holding temperature is 101 to 130 degrees Celsius based upon the temperature change 1 degree Celsius per minute. Mean when we go beyond 100 to 130, as we have discussed in later modules, in our previous module about that 30 is the suitable number to increase the temperature. So if we go and rise the temperature from 100 degrees Celsius to 130 degrees Celsius, overall there is a 30 increment, and per minute rise is 1 degree Celsius, then this information is also we can see in our next, when we know that the specific death rate for Bacillus stereothermophilus are different temperature ranges. So in this table we can see that this is the temperature. If we go increasing the temperature from 100 to 130 just by increasing the 1, and the specific death rate is, we can see here that 0.019 and then 0.025 and 0.032, 0.04 and so on. And then when we calculate the Dell factor, so there is also a gradually increase in the Dell factors. So if we go from 100 degrees Celsius to 115 degrees Celsius, the rise in the specific death rate from 0.019 to 0.666 as concerned the Dell factors, you can see here that 0.044 in case of 101 and 3.154 in case of temperature when there is a 115. So when we go from 116 to 130, so the specific death rate gradually increased and a maximum reached up to 17.524. As concerned the Dell factors, we can see here that rises up to 90.591. Mostly when we say that in autoclave process, when the temperature is mostly kept at 121 degrees Celsius, then the death rate is 2.538. At that time, the Dell factor is 12.549. Just keep in mind this situation when the temperature is 121 degrees Celsius and specific death rate, which we called as K, and this is the temperature and this is the delta factor. So if we just focus on this, then we can easily understand the next. So the rate of temperature change from 1 degree per minute, the Dell factor of heating and cooling, as we see in that directly from the table. So the temperature change deviate from 1 degree per minute, so the Dell factor may be altered by the simple promotion. So as the temperature increase, del factor also increased with some specific proportion. So if we take an example that if the fermentation broth was heated from 100 degrees Celsius, as I have already pointed out, that try to focus on 121 degrees Celsius. So if we say that 100 degrees Celsius to 1 in 30 minutes, and the cooling from 121 to in 17 minutes. So the rise in temperature takes more time rather to be the cooling in 7. Just an example. So if the rise time is 30 minutes and the down and cooling time in 17 minutes, so then the del factor for heating and cooling cycle may be determined by this. So from the table, as we have seen, if the change in the temperature had been 1 degree per minute, then the del factor for both heating and cooling cycles, as we have seen that when we are talking about the 121 degrees Celsius from the table, then the del factor was 12.549. But the temperature change in the heating cycle was 21 degree in 30 minutes. So therefore, the del heating, this is the del factor, multiplied by the time need utilized to raise the temperature up to 120 degrees Celsius. This is the basically to 121 degrees Celsius. So in 30 minutes, the overall rise in the temperature in 21 degree. So just by dividing this 21 degree, then the del factor of heating actually is 17.93. By the same case, when we are talking about the del cooling, so as we seen in our previous example, if the rising time from 100 degrees Celsius to 121 degree is 30 minutes, and if we say that the cooling time is 17 minutes, so the cooling from 121 degrees Celsius to 100 degrees Celsius, and the cooling time is 17 minutes, then the del factor easily, so the del factor at 121 degrees Celsius multiplied by the time and then the overall decrease in the temperature, then 10.16 is actually the del factor for the cooling cycle. So having calculated the del factor for heating and the cooling periods, the holding time at constant temperature may be calculated as we have discussed in this modules. So by this way, when we kept the temperature constant, then we can calculate the increase and the decreasing temperature, mean the heating and the cooling del factor.